Assalamualaikum and greeting from the Mac Services ST and BHD. In this topic, our team will presenting the mechanical properties and structure of 360L stainless steel on Petronas Twin Tower application.
Before we begin, allow me to introduce myself and three other group members who are well qualified and professional in this profession. I am Masita binti Daud, the project manager of this company. Later, we have Muhammad Ilham Shamil bin Muhammad Nirwan, senior engineer. Next, Muhammad Wildan Ashraf bin Muhammad Rostam, our design architect. And lastly, we got Muhammad Dani Akil bin Alwi, the industrial engineer of our company. Next, let's talk about our company background, which is Mac Services STN BHD. The term Mac stands for mechanical. We are focused and specialists on services related design engineering. Our company objective is to ensure that everyone is working in a safe and environmentally friendly workplace. We also offer our customer the best deal while maintaining high quality. We also specialize knowledge to ensure that technological operation go as planned. Thank you. I will pass to Wildan to continue our presentation.
Thank you, Masita, for the short brief just now. Hi and Assalamualaikum. My name is Muhammad Wildan Ashraf bin Muhammad Rostam. As a design architect from company Mac Service Sendirian Berhad, I am going to explain regarding our objectives and problems when performing tensile tests on 316L stainless steel grade using the standard test method. Our objectives are to describe our company's expertise, to understand the properties of the selected 316L stainless steel grade, and lastly to explain the method used to test the properties of the material. We are focusing on how to deal with these important factors when we held a test on 316L stainless steel grade, which is the relationship between the structural characteristics and tensile behavior of the material, the enhancement of the mechanical properties, and lastly, the performance of 316L if they are able to withstand the standard test methods during the tensile test experiment. And for the next brief, we will proceed with Muhammad Ilham Shamil as our senior engineer. Thank you.
Hi and Assalamualaikum. My name is Muhammad Ilham Shamil and I will be presenting about technical finding. Cold working is the process of strengthening metals through plastic deformation. This is made possible through the dislocation movement that are produced within a material's crystal structure. For the effect of cold working, based on graph, 316, which has a lower carbon, is more suitable because the microstructure has lower carbon attached. Grain size will relatively decrease with the increasing amount of dislocation density, which also will develop higher resistance to the steel. For the 316, which has gone through cold working and has high chromium, it will develop higher resistance to corrosion and higher resistance to higher temperature, which also will develop a higher resistance to scaling at high elevated temperature. I will pass this presentation to the next presenter. Thank you.
Assalamualaikum, my name is Muhammad Dani Akil and I'm going to talk about relationship between microstructure and mechanical performance. For microstructure, phases existing in materials, grains and grain boundaries. The original sample has a coarse grain structure while the cold roll has a finer grain structure. For the mechanical performance, the process evaluates the ability of materials. Mechanical properties of materials include elastic modulus, ductility, strength, stress strain, and elongation. Elongation of cold roll sample is lower than the original sample. In conclusion, we can conclude that we can determine what effect the stainless steel if go through deformation. We can produce a very quality product. Other than that, the hardness and the tensile strength of the sample increases. Moreover, we can improve the straightness and surface finish. And last but not least, the cold roll sample is better than the original sample in terms of microstructure, yield strength, tensile strength, and ductility. That's all from me and my group. Thank you.